At health facilities in low and middle income countries, individuals endure long waits and extensive travel to receive laboratory results, leading to delayed diagnosis and potential long-term damage. Our solution addresses this problem by introducing a groundbreaking diagnostic tool for early and confirmatory diagnosis of skin-neglected tropical diseases.
Molecular diagnosis involves DNA extraction, qPCR, and analysis of results. So DNA extraction usually takes 1 to 2 days, and it involves a stringent molecular lab setup with protocols. However, with this new technology, which is a cartridge-based technology, we have brought down the time from 1 to 2 days for mycobacterial DNA extraction to just 1 to 2 minutes. This cartridge is fabricated with several chambers with different solutions. If sample is introduced at one end of the chamber, DNA can be extracted at the other end of the chamber in just 2 minutes. PCR is battery operated and it's a miniaturized system. It has got 9 wells and one can detect up to 27 pathogens in one single sample or 3 pathogens in up to 9 samples. The PCR operates on a battery for up to 10 hours before it needs charging, and it can be connected with Bluetooth using mobile phone app. qPCR reaction can be set up using the reagents that are pre-mixed and freeze-dried, as you can see in the pouch here. This would avoid cross-contamination and effective setup of the PCR in a short duration of time. One can set up the PCR in 3 to 5 minutes instead of 3 hours on a routine laboratory bench. And these premixed reagents would enable faster and efficient amplification. Once amplified, the results are stored in the mobile phone app, and they can be shared with the cloud portal when internet is available on the phone. So this makes it more field compatible or point of care compatible. The whole system is field compatible. 1 to 2 minutes of mycobacterial DNA extraction using this cartridge-based system and qPCR in a battery-operated system at a near-field setting makes this diagnostic a game-changing for people affected by neglected tropical diseases. This system enables DNA extraction and PCR in the field setting or at the point of care setting. This also means that the patient need not necessarily come to the hospital to offer the sample. The whole test can be done at the patient's house, which includes DNA extraction, PCR, and analysis of the result.
We have already generated promising evidence for leprosy, Buruli ulcer, and COVID-19 using the Biomeme qPCR system. qPCR assays were standardized for leprosy and Buruli ulcer in collaboration with research partners in India and Ghana. Their utility was successfully tested at the Bedside, and we also demonstrated the feasibility of implementing the qPCR in the community for COVID-19 and recently Buruli ulcer using mobile laboratories in Ghana and the field connections in DR Congo. By partnering with labs in NTD endemic countries, we will continue to develop and validate qPCR assays for skin neglected tropical diseases prioritized in the target product profiles developed by the WHO Diagnostics Technical Advisory Group. Our results so far are highly promising. For BU, we achieved greater than 90% sensitivity and 99% specificity, and BU ghost strips are ready for regulatory approvals. For leprosy, the qPCR assays achieved 96% sensitivity and 100% specificity. To fully realize the potential of this game-changing diagnostic, we aim to scale up the Biomeme qPCR system worldwide over the next 3 years. Our plan is to develop and validate the system in 16 countries for 5 skin-neglected tropical diseases. Those are leprosy, Buruli ulcer, yaws, cutaneous leishmaniasis, and mycetoma. By partnering with us, you can contribute to accelerating the diagnosis of skin-neglected tropical diseases and alleviating the burden of delayed diagnosis for those who can't afford to wait.